Hello everyone, I am Disha Sharma from Acropolis Institute of Technology and Research from the Department of Information Technology. Today our topic is algorithm searching and sorting techniques in ADA. Topics are algorithms, designing algorithm, analyzing algorithm, asymptotic notations, heap and heap sort, introduction to divide and conquer technique, analysis, design and comparison of various algorithm based on the technique. Example, binary search, merge sort and quick sort. What is algorithm? An algorithm is a sequence of steps to solve a problem. An algorithm is the best way to represent the solution of a particular problem in a very simple and efficient way. A finite set of instructions that specifies a sequence of operation is to be carried out in order to solve a specific problem. An algorithm is a set of well-defined instructions designed to perform a specific set of tasks. Why algorithms are used? Algorithms are used in computer science to perform calculations, automatic reasoning, data processing, computations, and problem solving. So why we need algorithms? We need algorithms to understand the basic idea of problem, to find an approach to solve a problem, to improve the efficiency of existing techniques, to understand the basic principle of designing the algorithm, to compare the performance of algorithm with respect to other techniques. It is the best method of description without describing the implementation detail. The algorithm gives us a clear description of our requirements and goals of the problem to the designer. A good design can be produce a good solution to understand the flow of the problem. Characteristics of the algorithm. Algorithm must have unique name. Algorithm should have well defined inputs and output. Algorithms are well ordered, clear and unambiguous. An algorithm must be finite. Algorithm should not run for infinite. An algorithm must end at some point. It should not be consist infinite loop. An algorithm must be feasible. It must be executed with the resources available. An algorithm must be flexible in order to make a required changes. An algorithm must be language independent. Algorithm versus program. If we have an algorithm for a specific problem, then we can implement it in any programming language, meaning that the algorithm is independent from an programming language. Here, the some examples. The question is, write the algorithm to find the sum and product of given two numbers. So algorithm are, first we read a and b. Let's sum equal a plus b. Step 3, let product equal a into b, and the last we print sum and product. Here the example 2. Here we are swapping the two numbers. First we initialize the numbers a and b, and then we are taking temp as a variable, and then we swap it. Then in the last we print a and b. Analysis of algorithm. The analysis is a process of estimating the efficiency of an algorithm. There are two fundamental parameters based on which we can do analysis of algorithm. First one is time complexity, second one is space complexity. Time complexity refers to the amount of time needed by an algorithm to complete its execution. Space complexity is The space complexity refers to the amount of memory space needed by an algorithm to complete its execution. Design of algorithm. Design an algorithm is important before writing the program code, as the algorithm explain the logic even before the code is developed. The important aspect of an algorithm design included the creating an efficient algorithm to solve a problem in an efficient way using minimum time and space. To solve the problem, different approaches can be followed. Some of them can be efficient with respect to time consumption, whereas other approaches may be memory efficient. However, one has to keep in mind that both time consumption and memory uses cannot be optimized simultaneously. If we require algorithm to learn in lesser time, we have to invest it more memory invest in more memory, and if we require an algorithm to run with lesser memory, we need to have more time. Why study algorithm? Large problem size in an area of computational science which make performance very important factor. This is because longer time consumption means lower result, higher cost of computation. The study of algorithm gives us a language to express the performance as a function of problem size. Computational problem development step. First, problem definition, development of model, specification of an algorithm, designing an algorithm, checking a correctness of an algorithm, analysis of an algorithm, implementation of an algorithm, program testing, and in the end, documentation. Advantages of algorithm. Algorithms are easy to understand. Algorithms make it easy to understand and implement an actual program. An algorithm is debugging to detect any logical errors in the program. An algorithm is language independent. Disadvantage of algorithms. Designing an algorithms for a complex problem can be time consuming. Loops and branching statement are difficult to represent in an algorithm. For complex problem, it is difficult to understand the logic through algorithms. Analyzing algorithm. Analysis of algorithm is determination of amount of time and space resources required to execute it. Usually, the efficiency of running time of an algorithm is stated as a function relating the input length to the number of steps known as the time complexity or volume of the memory known as the space complexity. Why analysis of algorithm is important? To predict the behavior of algorithm without implementing it on a specific computer. By analyzing the different algorithm, we can compare them to determine the best one for our purpose. Type of algorithm analysis is first one best case, second one worst case, and last one is average case. Best case is minimum time required to execution of an algorithm. Worst case is maximum time required for an execution of an algorithm. Average case is average time required for an execution of an algorithm. Complexity of algorithm. Complexity of an algorithm is measured of the amount of time and space required by an algorithm to solve a problem. Types of complexity of an algorithm. The type of complexity are divided into two types. First one is time complexity, second one is space complexity. Time complexity is how much an algorithm is complex in terms of time or the amount of time taken by an algorithm to run or execute it. Space complexity is how much an algorithm is complex in terms of memory space or how much memory space is required for a successful execution of an algorithm. Next topic is asymptotic notation. Standard notation commonly used to calculate the running time complexity of an algorithm. First one is big O, second one is big omega, third one is big theta. So big O notation is the best way to express the upper bound of running time complexity of an algorithm. It measures the worst case complexity, that is maximum time required for an execution of an algorithm. Hence here the example, if fn function is smaller than constant g of n, then the function is function n equal omega of gn function. Read as f of n is big O of g of n. Here the function g of n is an upper bound of function f of n as g of n grows faster than f of n. Hence the complexity of fn can be represented as big O of gn. So big omega, the big omega notation is the way to express the lower bound of running time of complexity of an algorithm. It measured the best case complexity, the minimum time required for an execution of algorithm. The function is, if function is greater than equal to constant of g of n, then function equals omega of g of n. Read as function of n is big omega of g of n. Hence function g of n is lower bound for a function fn as gn is grows lower than fn. Hence the complexity of fn can be represented as omega of gn. Big theta. Big theta notation is the way to express the upper and lower bound of the running time complexity of an algorithm. It measures the best average case of complexity, average time required for execution of an algorithm. The function, if c1 gn is smaller than function is smaller than c2 of gn, then function fn equal to theta of gn. Read as f of n is big theta of g of n. Hence the function gn is an tight bond for a function fn as gn grow at the same rate of fn. Hence the complexity of fn can be represented as a theta of gn. So why we need the algorithm